Here we see another equation, which I will show is a quadratic form, or is quadratic in form. So the pattern that you want to look for, if you identify one variable, or one expression, look elsewhere in the equation and see if you can find the square of that expression. Okay, so if our expression is the square root of x, then its square is x. And here we see the square root of x and the square root of x squared. So the replacement that we can make, if we want to make our lives simpler, we can say, let's let u stand in for that thing, the square root of x. Then our equation becomes quadratic in nature. We get 3u minus 4 equals 0. And when we square this, we see that x is equal to u squared. So we can make that replacement as well. X is going to get replaced by u squared. So this is a little bit of a tricky concept at first. You want to do a few extras of these if you're not feeling comfortable with that idea. But this is not actually the only way we could solve this equation. Looking at this equation, this is also radical in nature. So we'll solve it this way, and then we'll get a little practice with radicals by seeing if we can solve it using the first approach we saw in this section. I think you'll find this strategy is a little bit nicer. So here we have our quadratic form, and we can see that this also factors. We can factor this as u minus 1, u plus 4 equals 0, which indicates that u equals 1 or negative 4. Okay. So now that we know what u is equal to, we can say u, 1, is equal to the square root of x, or u equals negative 4 is equal to the square root of x. So u is just a placeholder so that we can see what the quadratic actually is and then solve using our techniques. Alright, so now we can attempt to solve each of these equations, and these are both radical equations. I can solve by squaring both sides here. X equals 1 squared, so x equals 1. Or if I square both sides of this equation, we see x equals 16. Now it's worth noting that the square root of x equals negative anything has no solution. We're going to pretend that we forgot that, and we're going to carry on. Now, if at any point in your process you square both sides of an equation, you always need to check the solutions. So it's a good idea, but in this case we absolutely have to do it. So if we go back to the original equation, 1 plus 3 times the square root of 1 minus 4, that's equal to 1 plus 3 times 1 minus 4, and that's 4 minus 4, which is 0. And that checks out. So x equals 1 worked. Let's try x equals 16. So 16 plus 3 times the square root of 16 minus 4. That's 16 plus 3 times 4 minus 4. 16 plus 12 minus 4. That's not equal to 0. So x equals 16 is an extraneous solution and therefore not one of our answers. So that is how to handle quadratic forms. If you have a quadratic form, try to identify which is the smaller, in a sense, version of the variable and which is the version of that variable squared. So here we have something, and here we have something being squared. Now we said we would try to solve this one using the radical solution techniques. Okay, so our approach here is to isolate the radical first. I can do that by moving the x and the 4 over to the other side, so 3 radical x equals 4 minus x on the right. Okay, well now I'll go ahead and square both sides, even though I still have a 3 there, because if I divide both sides by 3, I'm going to have to square a third. So I'll square both sides right now. And don't forget you also have to square that 3. So 9 times x is equal, and we have to FOIL out 4 minus x squared. So that leaves me with 16 minus 8x plus x squared. And if you don't believe that, you can always factor that back, or you can FOIL it out, 4 minus x, 4 minus x. Alright, so now if we subtract the 9x over to the other side, we end up with 0 on the left, 16 minus 17x plus x squared. Well, I think a better way to write this might be x squared minus 17x plus 16 equals 0, which we can then solve using our quadratic techniques. So if I think about factoring this, I'm looking for numbers that multiply to 16 and add up to negative 17. Well, I think 16 and 1, where 16 is negative and so is 1. So that gives us our solutions, x equals 16 and x equals 1. So we already checked these. We saw that 16 was extraneous and x equals 1 was the only solution to this equation. So our quadratic form went pretty quickly, but so did using the radical approach. Now, most radical equations are not quadratic forms, but if they are, sometimes it's nice to use that approach, depending on which technique appeals to you. So let's look at one more of those, kind of a funny looking one to really drive the idea home. Okay, so here we see one final, very complicated looking equation. Again, in this section we're solving equations that are quadratic in form. So let me rearrange things a little so it's easier to see that we are in fact dealing with an equation that is basically quadratic. Now this involves some artful manipulation of rational exponents. Refer back to the preliminary section for the details on those rational exponents. Remember that a to the 2/3 is the same as the cube root of a squared, or the cube root of a all squared. This is the translation that I find most useful in this case. So what are we actually dealing with x plus 1 to the 2/3? This is really just x plus 1 under the cube root squared. Similarly, anything to the 1/3, the third power is just the same as the cube root. So I'll rewrite this expression as 2 times the cube root of x plus 1. Okay, so here we see we have the cube root of x plus 1, and here we see we have the cube root of x plus 1 squared. So that's the substitution. We're going to let u stand in for the cube root of x plus 1. So this will be 2u, and this will be u squared. And the equation that we have to solve now is a heck of a lot nicer to work with. Okay. In fact, factoring this is really nice. This is a perfect square trinomial, so we see this factors as u plus 1, u plus 1 again. So we see the only possibility is that u equals negative 1. Well, now we replace u with what it was standing in for, the cube root of x plus 1. So it turns out that the cube root of x plus 1 is actually equal to -1. And again, now we have a radical equation that we have to solve, but we have the techniques from the previous module to help us out there. So I want to get rid of that cube root. I'm going to cube both sides. So if I cube both sides, I get rid of the radical and I get what's inside x plus 1. Where on the right, -1 cubed is -1 times -1 times -1, which leaves us with -1. And then we can solve for x by subtracting 1 from both sides. It looks as though x equals -2. And then finally, we will check that out. So, as soon as we get to this point, we are solving a radical equation. We're raising both sides to a power, which means we have to check. Okay. So if I plug -2 into our original equation, -2 plus 1 to the 2/3 power, plus 2 times -2 plus 1 to the 1/3 power, plus 1. This is going to be a little tricky to simplify, but exponents come first. So -2 plus 1 is -1 to the 2/3, plus 2 times -1 to the 2/3, or 1/3 rather, plus 1. Alright, now remember that translation that we had. Anything to the 2/3 is the third root of that thing squared. And the 1/3 power is just the cube root of that thing. So we can see this as the cube root of -1 squared gives us 1. Here the cube root of -1 is -1. And finally the cube root of 1 is +1. So that x value, -2, checked out in our equation. That might be a nice one to use your calculator for. You want to make sure those exponents are in parentheses if necessary. But we had to check that one, and it was a good thing we did. We know for sure now that x equals -2 is a solution. We don't necessarily know that we found every solution, unless we did the entire process correctly. We might have missed something, so you want to watch out for this step right here. U plus 1 and U plus 1 both yield solutions. They just happen to be the same solution, so we only needed to follow that process to the end once. But that is solving quadratic forms. First, we identify what we can replace with u and what we can replace with u squared to turn our equation into something that looks quadratic. Then we solve for that stand-in variable, and then we unreplace. We plug the variable that we care about back in and solve from there.